Okay, picking up where we left off on the Module 10 review key. Here's number 21. I'm just going to go ahead and show you the answers because I went ahead and did the rest of it thinking the previous video was continuing, and it did not. So here are the answers. 21, your angle A rounds to 30 degrees. Angle B rounds to, well, would be 60 degrees. Side BA is 16.12. And on the last page, 22 is 0.59, 23 is 0.74, 24 is 0.51. The problem with Lisa and the bird's nest is 28 feet. And the problem with the building and its shadow is 20.2 feet. Okay, so you could just watch the part you need some help on. So number 21, since I wrote all over it previously, I went ahead and redrew it so I could talk about it from scratch. And in this one I have two side lengths given, but I don't have a single one of the acute angles. I don't know angle A and I don't know angle B. That means I'm going to have to find those. And it's when finding angles that I need to use my inverse functions. So I'm going to have that happen here. Let's go ahead and find angle A. It really doesn't matter which one you find first. If I'm going to find angle A though, this would be my opposite and this would be my adjacent. So that means I'm going to need to use the tangent function. So I say tan A equals opposite over adjacent. Now I'm trying to get tan away from A, so that means it comes over here as inverse tan, and that's inverse tan of 8/14. So that's what goes in my calculator. You don't put anything in your calculator until you have your variable alone, and now A is alone. So inverse tan means second tan, 8/14, 8 divided by 14, enter, and I get 29.74488. This is an angle, so I'm going to go to the nearest whole degree and get 30 degrees. Now since I rounded to get that, well, let me go ahead and find angle B before I talk about that. Angle B then, remember the two acute angles have to add up to 90, so 90 minus 30 is 60. Let's go ahead and find the missing side length AB, and then we'll be done with all the things we need to find in this triangle. Side length AB, since I already have this side and this side, I can just use Pythagorean theorem. So I'm going to go 8 squared plus 14 squared, get that answer, and then take the square root of that number. You always end Pythagorean theorem with square root. Okay, so now I've found all my missing information for this triangle, which was this angle, and this side length. Now let me just talk about what I was going to mention with the rounding to 30 part. If you just look at this triangle, you think it's a 30, 60, 90 triangle, which would mean I really wouldn't even have to do Pythagorean theorem. I could just do short leg, which is right here, times 2 to get this side. So why isn't the hypotenuse equal to 16, 2 times 8? Because this wasn't really equal to 30. This was rounded to 30. This wasn't exactly 30. It was 29 point something, and we rounded to 30. So that means this is close to 60. It's a rounded number. And so this is going to be close to 8 times 2, which it is. So I just wanted to clear that up in case you saw that and went, well, if it's a 30, 60, 90, why is it 16.12, not 16? Okay, looking at number 22, number 23, number 24, all of these are literally just put it in your calculator. So I'll go 22. Sine, so I hit sine, 3, 6, enter, and then I get 0.5877, etc. So you're literally just typing in. So for number 23, cosine, 4, 2, enter, and so on. Now down here, the Lisa problem. Keep in mind on all the angle of elevation and angle of depression problems that we're going to do, you will have the picture. So since the picture is provided for me over here, I really don't care about a lot of this information, but I do have to read through it to figure out what I'm trying to find. It says Lisa sees a bird's nest high in a tree. She decides to use trigonometry to estimate how high the nest is. She walks 15 feet from the base of the tree. So this is 15 down here, and because this is 15, that's what tells me Lisa's standing right here. So that's why I drew my Lisa over here. She measures the angle of elevation from the ground to the nest of 62 degrees. Well, I'm already shown that that's this angle right here is 62 degrees. Find how high the nest is above the ground. That's what tells me that I'm looking for this side length right here, the opposite side from 62. So now that I know that I'm trying to find the opposite and that 15 is my adjacent, I know that I'm working with opposite and adjacent, so it's going to be tangent. So when I start out, and this was after I solved it, when I start out, this goes tan 62 equals x over 15. That's what I have when I set this up. And then what I did over here was I multiplied both sides by 15. That gets my x alone, and that's when I put it in the calculator. So 15 times tan 62 gives me 28. It doesn't give me exactly 28, it gives me 28 point something, but this says to the nearest foot. So I'm going to round to the nearest whole number. Always make sure to go back and look at the problem in terms of asking yourself, what do I round to? Because usually the problem will tell you. If the problem doesn't tell you, a good bet is hundredths place. Last problem. Suppose the sun casts a shadow off a 35-foot building, and it showed me 35 feet is the height, is what they mean. If the angle of elevation to the sun is 60 degrees, so here's that, how long is the shadow to the nearest tenth of a foot? So what you have to figure out there is that the shadow lies along the ground. Shadows lay along the ground, so that's the length of the shadow would be measuring along the ground, and that's my x. Now I redrew this triangle here because it might be a little confusing that the 35 is over there instead of right here, but it's the same height on either side of the building. So here's my height of the building is 35. X is what I'm trying to find, and 60 is right here. So 35 is opposite, x is adjacent, and I'm going to use tangent. So when I first set that up, it says tan 60 equals 35 over x. Then I multiplied x to both sides to get it out of the denominator. That's the only time I multiply by x is if I have to get it out of the denominator. That cancels the x over here. Now x is out of the denominator, and I have x times tan 60 equals 35. Now I'm solving for x, and so I'm trying to get it alone, which means I need to get this tan 60 away from it. And I divide both sides by tan 60. So when I divide both sides by tan 60, I get x is alone, and on the other side is 35 divided by tan 60, and that's what goes in my calculator. So I do 35 divided by tangent of 60, and I get 20.2. Noticing this says, how long is the shadow to the nearest tenth of a foot? So it didn't come out exactly 20.2. I rounded to 0.2 because that's the tenths place. And that's it.